Okay, so now that you are very proficient at adding fractions with unlike denominators, you're good at that, right? You know how to do it. You find the common denominator, you make equivalent fractions, and you add them. So, today we're going to do lesson 6.3. Let's look at what we're learning. Fraction additions. Okay, we've already started on that last lesson. This one is fraction addition with estimation and reasonableness. Okay, so we're just going to be estimating when we're adding our fractions. We're not actually going to be finding the common denominator and doing all of that business. We're just going to estimate. So potentially it should be easier, right, if we're just getting estimates. Well, let's look at a real-life example of why you might need to be able to just estimate fractions. Victor is making punch for a party. He says the punch is probably going to fit in this 2-gallon container. Is he correct? All right, that's a real-life situation. Right, you're making punch, you have the recipe, here's the party punch recipe, and you're looking for a container, and you say, oh, here's a 2-gallon container. This is probably enough. Let's see if he's correct, and how did he figure that out without having to either get out his calculator or get out a piece of paper, find the common denominator, least common multiple, blah, blah, blah. He can just, in his mind, say, yep, this is probably going to work. Let's look and see.
Can you just pour it in there and see if it works?
Well, you can pour it in, and then you're like, oh, I've mixed up this recipe, but half it doesn't fit. And then you have to dump it in another container, a big mess, right? No, we're just going to get it first off by estimating. Okay, party punch recipe. 7/8 of a gallon of seltzer water, 1/12 of a gallon of lemon juice, 3/5 of a gallon of grape juice. If you add them all together, does it fit into a 2-gallon container? Well, you got to add up all these fractions. You can use benchmarks to estimate the sum. Remember our benchmark fractions that we talked about? 0, half, and whole. Remember how we figured out if it was closer to 0, right? If the numerator was really small compared to the denominator, it was 0. But if the numerator was really close, like 12/15, well, that's closer to 15/15, which is the whole. Or if it was like right in the middle, like 6/15 or 7/15, right? Somewhere there, like in the middle, 8/15. Right? So you kind of got to estimate, is it closer to go to 0, closer to be halfway, or closer to go to the whole? That's what we're going to be doing today. Sometimes a number line helps if you can visualize a number line. So right now if we have 7/8, is that closer to 0, half, or a whole? A whole. 7/8 is almost 8/8. 8/8 is a whole. So it's right here. So we're going to say 7/8 is basically 1 gallon. 1/12 of a gallon of lemon juice. Is that closest to 0, half, or whole? 0. Look at 1/12 out of 12 twelfths. If you only have 1/12, that's basically almost 0. 3/5 of a gallon of grape juice. Is 3/5 closest to 0, half, or whole? 0/5 would be 0. 5/5 would be a whole, and half of 5 would be like 2.5, right? 2 or 3 is right in the middle. So 3/5 is closest to a half of a gallon of grape juice. So if we add up 1 and 0 and a half, we get 1.5. So should it fit? Yes. Now it's just an estimate. It's just being reasonable with our guesses, right? So there's a potential that maybe it won't, but your best guess will be that it will fit. Okay, so Victor will make about 1.5 gallons of punch. Since 1.5 is less than 2, the punch will most likely fit into the 2-gallon container. So let's try some examples. All right, so here's some practices. Use benchmark, bless you. Use benchmark fractions to estimate the sum. 5/6 plus 7/10. Okay, use benchmark fractions. Let me freeze this up here. So think about those two. Let me freeze this so we can write on it. All right, what do you think? Look at 5/6 first. Is that closest to 0, half, or a whole? What do you think? 5/6, right? It's closest to a whole. 6/6 is a whole, so 5/6 is going to be closest to a whole. All right, here we go. Let me pull this up. Okay, so 5/6 is closest to 1 whole. All right, we've done that one. What about 7/10? What is that closest to? 0/10 would be 0. 10/10 would be a whole. 7/10 is going to be about a half. So our estimate for this is going to be 1.5. All right, what about this one? 9/10 is closest to what? 11/12. So this one is about? Good. 1/6.
0.
8/9.
1.
2/10.
0.
So this one is?
1.
Isn't this easy?
That's really easy.
1/8.
Wait, this is no 0.
Okay, wait. 1/8 is closest to 0. What about 6/11? Half. So the answer to this one would be? Okay, now let's go down. This says determine whether, let me tilt this down a little bit so these people can see. Determine whether the sum is greater than 1 or less than 1. That's what we're determining. So you're not just going to put your answer. The directions say greater than or less than 1. 1/6 is closest to 0. 5/12 is closest to half. So 0 plus a half is?
Lower. Less than 1.
It's less than 1. So the answer is less than 1. See how I did that? Less than 1. 1 would be greater than whatever the answer is. Does that make sense? Less than 1. 7/10 is about?
1. Half. Sorry. Half of 10 is 5.
Yes. So 7 is 2 away from 5, but it's 3 away from 10, right? So this is going to be about half. It's a little more than half, right? What about this one? So a half and a half is a whole. So wait a second. It wants to know if it's going to be bigger than or less than, greater than or less than a whole. You cannot say equal to.
Greater than. Less than.
Look at this. Now this is where it gets a little bit tricky. Those of you that said, oh, this is easy, look up here because this is where it gets a little hard. Okay, looking up here. You have a half plus a half, which equals a whole. It's saying, is it going to be greater than or less than? Well, look at this is really a little bit more than a whole, more than a half, or less than a half.
A little more.
This is a little bit more than a half, and this is what? A little bit more than a half. So actually, our real answer is going to be a little bit more than 1.
So.
Do you understand that? Just wait. If this is actually a little more than a half and a little more than a half, a little more than a half plus a little more than a half is a little more than a whole. Does that make sense? Yeah. Because actually your real answer is a little bit more and this is a little bit more. So you'd actually say your answer is going to be a little bit more than 1. Does that make sense? You have to look at your originals. If you end up with 1, you have to say, well, actually the real answer is going to be a little bit more than what I estimated. So let's look at this guy. 3/4. What do you do with 3/4?
It's a whole.
It's right in between a half and a whole, isn't it? So let's skip that one. Let's go to this one. 1/8 is?
0.
7/16 is? Okay, so you have a half. This could either be a half or a whole. You're trying to figure out if it's more than or less than 1. Well, if I put a half, then it would be 1. Does that make sense? But really, is this more than?
Yeah.
This makes it actually, because you have to use reasonableness. Like, I rounded this down to a half, and I rounded this down to a half. So my actual answer is going to be a little bit more than I'm guessing. Does that make sense?
Yeah.
Okay? Joey, I'd like you to come sit up here. I think it'll be better for you to totally focus. If you are rounding both of these answers down to a half, then you know your real answer is actually going to be more than what you're guessing. Does that make sense?
Yes.
So this is actually going to be, your answer is going to be more than a whole, right? Whatever your answer is, would be bigger than 1, because these are both actually a little bit bigger than a half. So you're using reasonableness, all right? This is where it takes more than just like, okay, step 1, step 2, step 3. This takes actually thinking, what am I doing? I'm taking this number that's a little bit more than a half and a little bit more than a half, and I'm rounding it to 1, but actually it's going to be a little more than 1. So what about this? 1/5 is
0.
closest to 0. 2/7,
0.
3/10.
0. No, half.
3/10 is closest to 5/10. So it'd be about a half. So this one actually is going to be what? This one's going to be less than 1. Do you understand how to write less than 1? Whatever your answer is right here is going to be less than 1. Okay, let's try another. Let's see if one of these gets a little more difficult. What about this guy? This guy is closest to half. Uh-oh. What's happening? This guy's closest to 1/2. 5/9 is closest to half. So you have a half plus a half. So here's one where you have to use reasonableness, okay? Half plus half is a whole, but it's saying, is it actually, the actual answer, going to be more than 1 or less than 1? Well, 6/11 is a little bit more than a half. 5/9 is a little bit more than a half. So your answer is going to be a little bit more than a whole. So we're going to say our answer will be more than a whole, right? Getting that? How you use reasonableness? This is just using benchmark fractions to estimate, but then you have to take it a step further and really kick your brain into gear and think, okay, what am I doing? Which way am I rounding? And what's my actual answer going to be? And this is important to know, because if you say, I have a recipe, so I say, I need 6/11 of grape juice, and I need 5/9 of apple juice. Is it going to fit into a 1 gallon container? You say, oh, well, that's about a half, that's about a half. Yeah, it'll fit. But will it really fit? No, because you actually rounded down a little bit, and you rounded down a little bit, so the actual answer is going to be up from your estimate, so it's not going to actually fit. Does that make sense? All these you need to think, is it going to fit into the 1 gallon container, or is it not going to? Okay? Oh, I see. She saw me teaching? Okay, I'll go over there in 1 second. 3/8 plus 1/5. 3/8 is closest to what? Half. 1/5 is closest to?
0.
So this is going to be
Less than.
1/2 plus 0 is a half. So it'll be less than 1. Does that make sense?
Yeah.
So Romy, we have 3/8 is a half. 1/5 is a whole is 0. So 1/2 plus 0 equals 1/2.
Okay.
Got it?
I thought that was 1/2.
Got it. Okay. Let's look at this one, number 12. 2/3 plus 5/8 plus 1/5. 2/3 is closest to what? It could go either way. It could go a whole, it could go a half, so let's just wait on that one. 5/8 is closest to? 1/5 is closest to?
0.
Okay, so this one, if we say a half, half plus 0, that equals 1. But actually, 2/3 is more than a half, isn't it? 5/8 is more than a half, and 1/5 is actually more than 0. So all of these, I'm estimating lower. So my actual answer is going to be higher. Does that make sense? This is going to be more than a half, and more than 0. So my answer is actually going to be more than 1. Is everybody getting how you do that? Last one. 1/8 is closest to? 2/5 is closest to? 1/5 is closest to? 0 plus 0 plus 0 equals 0. Well, my answer is actually going to be a little bit more than 0, right? This is a little bit more than 0, a little bit more than 0, a little bit more than 0, so my answer is going to be a little bit more than 0. But my answer is still going to be less than 1, right? Okay, so I think you all got that. Hold tight. Let me go to my next page here. Okay. I've got the teacher's edition up here. Hold tight. Let me change this to student edition so you don't have the answers. Okay. Alrighty. Let's look up here. I need the focus of the people who are in the back, okay? I gotta wait till everybody's looking with their eyes on the board so you know how to do your assignment, okay? Let's look up here. Estimate the sum. You guys won't have any problem with that, but look at this one. This says, tell if you agree or disagree with this statement. the sum of 6/7 and 4/9 is about 1.5. Well, what is 6/7? That's about 1 whole. 4/9 is about? So do we agree? Yes, we agree. Yay. Right? The sum of 3/4 and 11/12 is about 2. All right, 3/4 is about what? And 11/12 is about 1, so it's about 2. Yay. Yes. We're going to say we agree. Whoa, look at this one. We got mixed numbers now, so let's pay close attention. We have 1 and 4/10. 4/10 is about what? Half. So we're going to say this is about 1.5. And what is 2 and 1/8 closest to?
2.
Right? Because this is about close to 0. So we're going to say 2. So the answer is about 4.5. Yes or no? No, it's about 3.5, right? No, we don't agree with that one. Okay? That's how we're going to do these. Now let's move a step further, and they start putting these letters in your math problems to get you ready for algebra. Here we go. Find a value for n that would make a proper fraction and it would make the sum greater than 1. Look at this. We've got a lot to do with this one. Okay, we need to, first of all, recognize this. Let me make this big. 3/5 plus how many sevenths? We want to make it a proper fraction and we want to make it greater than 1. So 3/5 is closest to what? Closest to a half. No, it would be closest to a half, right? It's almost exactly half. 2.5 would be half. So if this is a half, what could we make n that would make this greater than 1? What could n be to make this plus this greater than 1? Bria.
6.
Let's try it. If this is 6/7, then 6/7 is closest to 1, and 1 plus a half is definitely bigger than 1. Any other numbers that we could use that would make this bigger than 1? Jackson? 5/7. Let's see. 5/7 would make this 1. So that still keeps it bigger than 1. Anything else? Yes? 7/7. Oh, it says a proper fraction, so that would be improper, but you're right, but it would not be proper. What about?
4.
4, let's see. If we have 4/7, that's closest to what? A half. Is this bigger than 1? Let's think about it. This actual answer is a little bit bigger than a half, and this is a little bit bigger than a half. So will your answer be a little bit bigger than 1? Yes, it will. All right, let's do one more, and then I think you've got the hang of it. Let's do a less than 1. So what can we put for n that will make this value less than 1? Okay, well, we've got 5/9, and that would be what? What would that be, Bria?
I have a question about number 35.
Okay.
Would it still work if you did 6/7 or 5/7?
Yes.
Okay.
6/7 works, 5/7 works, and 4/7 work. Yes. So going back to this one, 5/9 is closest to what benchmark? Lydia? A half. Very good. Now, we need something plus a half that is going to make the sum less than 1. So what does this have to be? This is going to need to be what? A fraction that makes this 0. What fraction could make this closest to 0? Zachary?
1.
Right. 1/4 would make it closest to 0. What about 2/4?
No, that's half.
Right, that's half. So really it's going to be a 1 that's going to make this, n would equal 1. Okay, good job, guys. I think you really got that. So for homework, today's Friday, so we can't do our homework. So your homework is going to have to be used. What's it?
I have it.
Well,